Now here the question is, we are given a number which is of the form 7, 5, 5, 5, 7, and here we have total R5s, and then we have these two numbers 7. So basically it is R plus 2 digit number. So first and last digit are 7 and remaining digits are 5. So consider the sum as, which is 77 plus 757 plus 7557 and goes all the way up to 75557, and here we are taking them 98 times. So basically it's a 100 digit number. Now it says we have to express this sum as 7 and then 99 times 5, 7 plus m by n, where m and n are natural numbers less than 3000. Find the value of m plus n. So somehow we have to solve this series. Now generally when I see this pattern, I know we have to use difference somewhere. So what we'll do is we'll write 10s. So we'll multiply this series with 10 and we'll shift the series by 1 unit. So here it will be 770. Here it will be 7570. And this term here will be 755570. So here we have 98 5s and then we have 70. Now what we'll do is we'll subtract first from second. So if we subtract first from second, now 10s minus s is basically 9s. Now this is minus 77. Now 770 minus 757. Essentially this is 70 minus 57. So it will be this 13. Now here also 75. It's of no use. 70 minus 57 is again 13. I will continue up to this term, which is 13 plus this 7, 5, 5, 5, 98 times, and then this is 70. Now first thing is, how many 13s do we have? So we have started with 1 and we have gone up to 98 5s. So this 13, it appeared 98 times. So we can write this 9s will be minus 77 plus 13 into 98 plus, now here we need 7, 5, 5, 5, 5, 5, 7, 99 times. So what we'll do is we'll subtract 13 and we'll add 13. So here we'll add 13, and if we subtract 13, it'll become 7, 5, 5, 5, 5, 7, and now this is 99 times 5. So basically this is 9s and this is 13 into 99 minus 77 plus 7, 5, 5, 5, 7, 99 times, which we need in the question. So it will be 1210 plus 7, 5, 5, 5, 5, 99 times 7, or we can write this as 1210 plus 7, 5, 5, 5, 5, 99 times 7 whole divided by 9. Now we have put it in this form. Now this is your m and that's your n. We need to find the value of m plus n. So value of m plus n is 1210 plus 9. So there will be 1219, and that is the answer to this question. Now here the question is, find the condition that roots of the equation x cube minus px square plus qx minus r equals to 0, they are in AP, and hence solve this given equation. Now suppose roots of this equation are a minus d, a, and a plus d. Now if we write S1, which is sum of roots alpha plus beta plus gamma, we'll get 3a equals p, or a is p by 3. Now since a is root of this equation, it'll satisfy this equation, so we can write p by 3 cube minus p by 3 square plus q into p by 3 minus r equals 0. Now we can write this as p cube minus 3p cube plus 9p cube minus 27r equals 0, or we can write this as 2p cube minus 9p cube plus 27r equals 0. So if roots are in AP, then the condition is 2p cube minus 9p cube plus 27r must be equal to 0. Now we are given this quadratic equation, which is x cube minus 12x square plus 39x minus 28 equals 0. Now if we compare it with this given equation, we can write p as 12, q as 39, and then r as 28. Now if we calculate 2p cube minus 9p cube plus 27r, there will be 2 into 12 cube minus 9, 12 into 39 plus 27 into 28, and if we'll solve this, we'll find it is equal to 0. So that means roots of this equation, they are in AP. Now if the roots are in AP, let the roots be a minus d, a, and a plus d. Now we can write S1, which is sum of all the roots. So it will be this 3a, and 3a equals 12. So value of a is 4. And then we can write S3, that is product of all the roots, and it will be this a into a square minus d square, and that will be equal to 28. Now we put a as 4. So it will be this 4, and then 16 minus d square equals 28. This is 7. So d square is 9. That is value of d is plus or minus 3. So whether we take d as plus 3 or minus 3, we'll end up getting the same result. So a minus d will be 1, a is 4, and a plus d is 7. So the three roots of this equation are 1, 4, and 7. Now the question is, if ax square plus 2bx plus c equals to 0 and a1x square plus 2b1x plus c1 equals to 0 have a common root. So they both have a common root, and it also says a upon a1, b upon b1, and c upon c1, they are in AP. Then show that a1, b1, c1, it is in GP. Now the first thought in this question is to find condition of common root and then maybe try this AP condition to prove that a1, b1, c1, they are in GP. But this method, it proves to be very lengthy. So what we'll do is we'll say these three numbers, they are in AP, and let these numbers be k minus d, k, and k plus d. So that means a upon a1 is k minus d, b upon b1 is k, and c upon c1 is k plus d, or we can write a as k minus d into a1, b as k into b1, and c as k plus d into c1. Now if we put it in this equation, we can write this equation as k minus d a1 x square plus 2 k b1 x plus k plus d c1 equals to 0. Now we'll take terms of k together, so we can write k, and this is a1 x square plus 2b1x plus c1, and then we'll take terms of d together, so it'll be this minus d, and then we'll have a1 x square minus c1 equals 0. Now let the common root for both the equations be alpha. So if alpha is common root, then we can write a alpha square plus 2b alpha plus c equals to 0, and then a1 alpha square plus 2b1 alpha plus c1 equals to 0. Now alpha is common root, so we'll put x as alpha, we can write k, and this is a1 alpha square plus 2b1 alpha plus c1, and minus d, and here will be this a1 alpha square minus c1 equals 0. Now we know that a1 alpha square plus 2b1 alpha plus c1, it is 0, so this value will be 0. So from here the condition that we'll get is a1 alpha square minus c1 equals to 0, or alpha square is c1 by a1, that is alpha is under root c1 by a1. Now alpha is common root of both the equations, so alpha is going to be the root of the equation a1x square plus 2b1x plus c1 equals to 0. So we'll put the value of alpha here, so we'll get a1 c1 upon a1 plus 2b1, and here will be under root of c1 upon a1 and plus c1 equals to 0. Now I'll cancel, and we may have a plus sign or a minus sign here, so it will be this plus minus. So from here we can write plus minus 2b1 under root c1 upon a1 will be equal to minus 2c1. Now this 2 and 2 will cancel, so you get plus minus b1 equals minus under root of a1 c1, or simply we can write b1 square equals a1 into c1, which means a1 b1 c1, they are in GP, which is what we need to prove in this question. In most of the exams you'll find this question other way around. So what generally they do is they'll give you this equation ax square plus 2bx plus c equals to 0, and this other equation a1x square plus 2b1x plus c1 equals to 0, and then they'll say they have a common root, and then they'll give the condition that a1 b1 c1, they are in GP, and then they'll ask you find a upon a1, b upon b1, and c upon c1, they are in what. So when the question is given like that, we know that for this second equation a1 b1 c1, they are in GP. That means b1 square equals a1 c1, Now if we find discriminant for this equation, there will be 4b1 square minus 4a1c1, there will be 0. So it simply means that roots of this equation are equal. So this equation will have two equal roots, alpha and alpha. Now if we write sum of roots, we can write 2 alpha equals minus 2 b1 upon a1. So from here we get alpha as minus b1 upon a1. Now since alpha is going to be the common root, it is going to satisfy this first equation. So we'll put the value of alpha in this first equation. So we'll get a, and here will be this b1 upon a1 whole square, and then it will be this minus 2b b1 upon a1 plus c equals 0, and we have to divide everything with b1 square. So we can write a upon a1 square minus 2b a1 b1 plus c upon b1 square equals 0. Now we know that b square is a1 c1. So we'll write this b1 square as a1 c1. So we'll get a upon a1 square minus 2b a1 b1 and plus c upon a1 c1 equals to 0. We'll take a1 common. So from here we'll get this condition that twice b upon b1 equals a upon a1 plus c upon c1, which means a upon a1, b upon b1 and c upon c1, they are in AP. So this is how we prove that a upon a1, b upon b1 and c upon c1, they are in AP. And at times they may ask you a1 upon a, b1 upon b and c1 upon c. So if they are in AP, then their reciprocals, they will be in HP. Now here the question is, if A, B, C, D and E be 5 numbers such that A, B, C, they are in AP, B, C, D, they are in GP, and C, D and E, they are in HP, that says prove that A, C and E, they are in GP. Now condition of an AP is B equals A plus C by 2. Here C square will be equal to B into D, and here D is equal to 2CE upon C plus E. Now first is we have to prove that A, C and E are in GP. So for this first one, we have to relate A, C and E. So for this, what we'll do is we'll take this third one and multiply it with B. So we'll get BD equals twice CE upon C plus E into B. Now B into D is C square. So it will be the C square and then 2CE upon C plus E, and this B is A plus C by 2. Now this 2 will cancel. This C will cancel. So we get C square plus EC, and that will be equal to AE plus EC. Now EC will cancel. So from here we can say C square equals AE, or AC and E, they are in GP. So that's our first part. Now the second part says prove that E equals 2B minus A whole square upon A. So we have to find E in terms of A and B. So for the second one, we have to find E in terms of A and B. Now from here we can write C equals 2B minus A, and if we put C here, we can write D as 2B minus A whole square upon B, and this D is also equal to 2CE upon C plus E. So this 2, and we'll replace C with B minus A, 2B minus A. So it will be this 2B minus A into E upon 2B minus A plus E. Now this 2B minus A will cancel, we can write this as two b minus a whole square plus 2b minus a into e, and they'll be equal to 2be. Now 2b into e will cancel, so we'll get a into e as 2b minus a whole square, or e is 2b minus a whole square upon a. Now this third part is, if a is 2 and e is 18, find the value of b, c and d. Now we'll put e as 18, then we'll get 2b and a is 2, 2b minus 2 whole square upon, and a is 2, so you'll get 2b minus 2 equals root 36, which is plus or minus 6, or b minus 1 equals plus or minus 3. So if we take plus sign, we'll get b as 4, and if we take minus sign, we'll get b as minus 2. Now c is 2b minus a. We want to write c. So this c, it will be 2b minus a. Now if b is 4, then c is 8 minus 2, 6. And here, if b is minus 2, it will be minus 4 minus 2. Then value of c is minus 6. And now we have to find the value of d. And we know that d is twice ce upon e plus c. So here, this d will be 2, 6 into 18 upon 24. So this is 2. So value of d is 9. So value of b, c and d, it can be 4, 6, 9. And here it will be this 2, c is minus 6, e is 18, and then e plus c is 12. So it will be minus 18, or it will be minus 2, minus 6 and minus 18. And that is the answer to this question. Now here the questions, we are given this infinite series, which is 1 into 3 upon 2 plus 3 into 5 upon 2 square plus 5 into 7 upon 2 cube up to infinite. So this series is actually 3 by 2, 15 by 2 square, 35 by 2 cube up to infinite. Now we'll write this series once again, and we'll multiply its common ratio 1 by 2, and we'll displace this series by one term. So there will be 3 upon 2 square, 15 upon 2 cube up to infinite, and if we subtract, we'll get this s by 2 as 3 by 2, and it will be this 12 upon 2 square plus 20 upon 2 cube up to infinite. We'll need to write one more term. Now the next one is 7 into 9 upon 2 to the power 4. So it will be this 63 upon 2 to the power 4, and this is 35 upon 2 to the power 4, and this is 28 upon 2 to the power 4 up to infinite. Now again we write the same series and multiplying it with its common ratio 1 by 2 and displacing it by one term. So it will be this s upon 2 square, and this is 3 upon 2 square, 12 upon 2 cube, 20 upon 2 to the power 4 up to infinite, and we subtract this, we get s by 4, this is 3 by 2, this is 9 by 4 plus and here will be this 8 upon 2 cube, 8 upon 2 to the power 4 up to infinite, and this is nothing but an infinite GP. So we can write this as S by 4, and this is 6 by 4 plus 9 by 4. It will be 15 by 4 plus, and sum of an infinite GP is A. First term is 1 upon 1 minus, and common ratio is 1 by 2. So it will be S by 4 equals 15 by 4 plus 2, which is 23 by 4. So value of S is 23. So sum of this series is 23. Now here the question is, interior angle of a polygon are in AP. So we have a polygon whose interior angles, they are in AP. The smallest angle is 120 degrees. So A is 120 degrees and their common difference is 5 degrees. So D is 5 degrees. Find the number of sides of polygon. So we have to find number of sides. Now we know that sum of interior angles of a polygon, it is given by n minus 2 into 180, and it's simple to work out. So we'll have n triangles. Sum of all the angles of a triangle will be n into 180, and from this sum we'll subtract all these angles which are at the vertex or which are at the center of this polygon. So it will be minus 360. So we can write this as n minus 2 into 180 degrees. So we have first term, common difference, and sum of all the angles. We should be able to find the value of n. So sum of all the angles will be n by 2, 2a plus n minus 1 into d, and they'll be equal to n minus 2 into 180 degree. Now we can cancel 5 here. So this is 5, 24, and this is 36. Now this is n, and here it is n, 48 minus 1, n plus 47, and here will be this n minus 2 into 72. So we write n square plus 47n, it is equal to 72n minus 144. So it will be this n square minus 47 minus 72. 25n plus 144 equals 0. So this is simply n minus 16 and n minus 9 equals 0. So value of n is either 16 or value of n is 9 for the sum to be equal to n minus 2 into 180 degrees. Now here, before jumping on to any conclusion, we must also see any angle must be less than 180 degrees. It should be convex polygon. So that means any angle or any an which is a plus n minus 1 into d should be less than 180 degrees. So if we divide it with 5, we can write 24 plus n minus 1, it should be less than 36, or n should be less than 13. So the only answer that we are going to accept in this question is n equals 9. So answer is n equals to 9, and we are going to discard n equals 16. Now this second question is similar to the first one. It says interior angle of a convex polygon form an AP whose common difference is 4. So it is an AP whose common difference is 4 degrees and its largest angle is 172 degrees. We have to find number of sides. Now again in this, sum of all the angles will be equal to n minus 2 into 180. Now in this case, because we are not given first term, so what we'll do is we'll reverse this AP. starting from 172, and we'll take its common difference as minus 4 degrees. So it'll be this n by 2 and then 2a, which is 2 into 172 degrees plus n minus 1 into minus 4 degrees. Now here it will be n minus 2 into 180, that will be equal to n into, now this is 172 plus 2, 174 minus 2n, so we can write this as 2n square, and then 180n minus 174n, that will be plus 6n minus 2 into 180 equals 0. Now we'll divide everything with 2, so it will be this n square plus 3n minus 180 equals 0, which is n plus 15 into n minus 12 equals 0. Now n, it cannot be negative, so the only value of n we get here is 12. So here the answer is value of n is 12. Now here the question is, if there are n AMs which are inserted between 1 and 31, so between 1 and 31, n AMs are inserted. Now it says such that 7th mean upon n minus 1th mean, it is equal to 5 by 9. Find the value of n. Now if we find its common difference, it will be simply b minus a, which is 30 upon n plus 1. So this common difference will be 30 upon n plus 1. Now this a7 will be a plus 70, which is 1 plus 210 upon n plus 1, and there will be n plus 211 upon n plus 1. So that's your a7. And then we need to find a n minus 1. So it will be this 1 plus n minus 1 into d, it will be 1 plus n minus 1 into 30 n plus 1, which is 31n minus 29 upon n plus 1. Now if we take the ratio a7 upon a n minus 1, here n plus 1 will cancel, we get n plus 211 upon 31n minus 29 as 5 by 9. Now we can write 9n plus 1899 will be equal to 155n minus 145. Now this is 146n equals 1899 plus 145, which is 2044. So from here we get the value of n as 14. So basically 14 AMs were inserted between 1 and 31. Now here the question is, find the sum of the series, which is 7 plus 77 plus 777 up to n terms. Now what we'll do is, we'll take 7 common, we'll multiply and divide everything with 9. So it'll be 7 by 9, and then it'll be this 9 plus 99 plus 999 up to n terms. Now we can write this as 7 by 9, and 9 is 10 minus 1, 99 is 100 minus 1, 999 is 1000 minus 1 up to n terms. So it'll be this 7 by 9, and then we have this GP 10 plus 100 plus 1000 up to n terms, and then we'll have this minus 1 minus 1 minus 1 n times, and there'll be simply minus n. Now this is 7 by 9, and sum of this GP is a into r to the power n minus 1 upon r minus 1 minus n. So what we'll do is, we'll take this 9 common, so we can write 7 upon 81, and it'll be 10 to the power n plus 1 minus 10 minus 9n, and that is the answer to this question. Now here the question is, find the sum of the sequence, and it is 1 upon 1 plus 1 square plus 1 to the power 4, 2 upon 1 plus 2 square plus 2 to the power 4 plus 3 upon 1 plus 3 square plus 3 to the power 4 up to n terms. Now what we are going to do is we are going to write its general term, its rth term. Now for the first term we have 1, for the second term we have 2. So for this rth term we'll have this r, and it will be 1 plus r square plus r to the power 4. Now what we'll do is we'll add r square and we'll subtract r square. We can write this as r upon, and this is a plus b whole square. So it will be 1 plus r square whole square minus r square, which is a plus b into a minus b. So it will be r upon 1 minus r plus r square into 1 plus r square. Now what we'll do is we'll split this term using partial fraction, and we'll introduce a minus sign. So we can write this as tr, and this is 1 by 2, and here will be 1 upon 1 minus r plus r square minus 1 upon 1 plus r square. Now here this 1 plus r square will cancel, and 2 and 2 will cancel, so we'll get the same term. Now our first term will be 1 by 2, and if we put r as 1, it will be 1 upon 1 minus, and if we put r as 1, it will be 1 by 3. Now the second term will be 1 by 2, and here it is 5 minus 2, 1 by 3 minus, and this is 1 by 7. Now this third term will be 1 by 2, and this is 10 minus 3, 7, and here will be 9 and 4, 13. And we continue up to nth term, which is 1 by 2, 1 upon 1 minus n plus n square minus 1 upon 1 plus n square. Now if we add all these terms, we'll get sum of first n terms. So Sn is basically sum of t1 plus t2 up to tn. Now if we add them, these successive terms, they'll cancel, and what we're left with is this first term and last term. So this Sn will be 1 by 2, and then 1 minus 1 upon n square plus n plus 1, or simply n square plus n upon 2 into n square plus n plus 1. And that is the answer to this question. Now here the question is, if one AMA and two GMs P and Q be inserted between two given numbers, then show that PQ plus QQ is equal to 2APQ. Now let the two numbers be X and Y. Now it says we have inserted one AMA between X and Y. So basically this A will be X plus Y by 2. And we have inserted two GMs P and Q between X and Y. Now its common ratio R will be simply Y by X to the power 1 by 3. So this P, it will be X into R, which is X to the power 2 by 3 into Y to the power 1 by 3, and Q, it will be P into R, which is X to the power 1 by 3 into Y to the power 2 by 3. So now we have PQ and we also have A. Now it says we need to find PQ plus QQ. Now if we take their Q, we can write this is X square Y and this is XY square. So we can take XY common and then it will be this X plus Y. Now we multiply P and Q, it will be X to the power 2 by 3 into X to the power 1 by 3, which is simply X. In the same way, it is Y to the power 1 by 3 into Y to the power 2 by 3, which is Y. So we can write this XY as PQ, and we know that X plus Y is nothing but 2A. So it will be this 2A into PQ, which is what we need to prove in this question. Now it says sum of n terms of two arithmetic series are in the ratio 7n plus 1 upon 4n plus 27. Find the ratio of their nth term. Now we are given the ratio of their sum of n terms. So let it be Sn and S dash n. A sum of n terms for this first series be n by 2, and this is 2a plus n minus 1 into d. And for the second series it will be this n by 2 and then 2a dash plus n minus 1 into d dash, and it is equal to 7n plus 1 upon 4n plus 27. Now this n by 2 will cancel. Now what we'll also do is, on the left hand side we'll divide everything with 2. So we can write a plus n minus 1 by 2 into d upon a dash plus n minus 1 by 2 into d dash. It is equal to 7n plus 1 upon 4n plus 27. Now we have to find ratio of their nth term, and we know that ratio of their nth term will be Tn upon T dash n, and will be a plus n minus 1d upon a dash plus n minus 1 into d dash. So basically on the left hand side we need n minus 1 and not n minus 1 by 2. So what we'll do is we'll replace n minus 1 by 2 with, suppose, n minus 1. Now here we can write n equals 2n minus 1. So what we'll do is we'll replace n with 2n minus 1. Now we replace n with 2n minus 1. We can write a, and here will be n minus 1d upon a dash plus n dash minus 1 into d. And here also we'll replace n with 2n minus 1. So there will be 7 into 2n minus 1 plus 1 upon 4 2n minus 1 plus 27. Now this is 14n minus 6 upon, and here it will be 8n plus 23. Now we can change this capital N into small n. We can write a plus n minus 1 into d upon a dash plus n minus 1 into d dash, which is basically ratio of their nth term will be equal to 14n minus 6 upon 8n plus 23. So basically the shortcut is, if you have Sn upon S dash n as some function of n, Fn, then ratio of their nth term Tn upon T dash n will be simply F 2n minus 1. You just need to replace n with 2n minus 1. Now here the question is, if S is the sum, P is the product, and R is sum of reciprocals of a GP, then find the value of P square R upon S to the power n. Now we have this GP, which is AR square up to AR to the power n minus 1. Now we know that sum of this GP will be A 1 minus R to the power n upon 1 minus R. Now product of all terms will be this A into AR square up to AR to the power n minus 1. So there will be A into A into A n times. That is A to the power n. And then R to the power 1 plus 2 plus 3 up to n minus 1, which is n minus 1 n by 2. So this is A to the power n, R to the power n minus 1 by 2. And then we'll have to find sum of reciprocals, which is 1 upon A plus 1 upon AR up to 1 upon AR to the power n minus 1, which again is a GP whose first term is 1 by A and its common ratio is 1 upon R. So it will be 1 upon R to the power n minus 1 upon 1 upon R minus 1. So if we simplify this, we'll get this as 1 minus R to the power n upon A R to the power n minus 1 into R minus 1. Now we have to find the value of P square into R by S to the power n. So we need to find P square into R by S to the power n. Now P square will be A to the power n R to the power n minus 1 by 2 whole square, and then r by s. This is 1 minus r to the power n upon a r to the power n minus 1, and this is 1 minus r, not r minus 1. So it will be this 1 minus r into, and this s is 1 minus r upon a, 1 minus r to the power n. Now they'll cancel. Whole to the power n. This is a to the power 2n, r to the power n, n minus 1, and here it will be 1 upon a to the power 2n and r to the power n, n minus 1, which will cancel. So value of this expression is 1, and that is the answer to this question. Now here the question is the first and last term of an AP are a and b. So we have an AP whose first term is a and last term is b, and there are altogether 2n plus 1 terms. It says a new series is formed by multiplying each of the first 2n elements by the next term. Show that sum of the new series is this value. Now we know that this b is 2n plus 1th term. This b will be a plus 2n into d. So common difference of this AP will be b minus a upon 2n, and that's our first result. Now what they have asked for is this summation AR into AR plus 1, where R varies from 1 to 2n. We need to find this sum. A1 into A2 plus A2 into A3 up to A2n into A2n plus 1. Now we know that its R term is A plus R minus 1 into D, and its R plus 1th term is A plus R into D. Now if we simplify this, we can write this as this summation R varies from 1 to 2n, and here will be this A square plus R square minus R into D square, and then we'll have this AD into 2R minus 1. Now summation A square is nothing but A square into 2n plus this is D square, and then summation R square. Summation R square is 2n plus 1, 4n plus 1 whole divided by 6, and then minus summation R, which is 2n plus 1 by 2, and plus a into d, and 2r minus 1 is sum of odd numbers from 1 to 2n, which is simply 2n square. Now we can simplify it. We can write this as a square into 2n plus d square, and here we will take 2n plus 1 by 6 common, then we get 4n plus 1 minus 3 and plus AD into 2n square. Now we'll substitute the value of d, and we know that d is b minus a upon 2n. So now it will be this s, and this is 2n a square, and this is b minus a whole square upon 2n square, and 2n square will be 4n square 2n into 2n plus 1 by 6 into 4n minus 2 and plus a, and this is b minus a upon 2n into 2n square. Now here 2n and 2n will cancel, so we'll get here 2n, and this 2 will also cancel, so here will be this 2n minus 1. So we can write this as 2n a square plus b minus a whole square into 4n square minus 1 upon 6n, and here also 2n will cancel, so you'll get 2n AB minus A square. Now 2 and A square will also cancel. So this sum will be B square plus A square into 4n square minus 1 and then minus 2ab. So there will be minus 2ab into 4n square minus 1 and this is plus 12n square ab whole divided by 6n. So we can write this sum as b square plus a square into 4n square minus 1 and we'll take 2ab common. So it will be this 6n square minus 4n square, which is 2n square plus 1 whole divided by 6n, which is what we need to prove in this question. Now here the question is, in an AP of which A is the first term and if sum of the first P terms is equal to 0, so it says sum of first P terms is equal to 0, then show that sum of next Q terms is this value. So we have to find sum of next Q terms. So what we can do is we can find SP plus Q minus SP to find sum of next Q terms. Now essentially SP is 0, so it is nothing but it is SP plus Q. Now if SP is 0, we can write P by 2, 2A plus P minus 1 into D, it should be 0, or 2A plus P minus 1 into D, it will be 0. Now SP plus Q is P plus Q by 2, it will be 2A plus P plus Q minus 1 into D, which we are going to write as P plus Q by 2, and this is 2A plus P minus 1D plus QD. Now this value, it is 0, so it will be this P plus Q by 2 into QD. Now this D is nothing but it is minus 2A upon P minus 1. So we can write this as P plus Q by 2 into Q, and this is minus 2A upon P minus 1. Now this 2 and 2 will cancel, so it will be this minus A P plus Q into Q upon P minus 1, which is what we need to prove in this question. Now here the question is, this sequence A1, A2, A3 up to A98, it satisfies this relation, which is an plus 1 minus an, it is equal to 1. That means it is an AP because successive difference is constant and it is equal to 1. So value of D is 1 and say its sum is equal to 4949. So sum of these 98 terms, it is 4949. Now we know that sum of 98 terms will be 98 by 2, 2A plus n minus 1. So there will be 97 and D is 1 and it is equal to 4949. Now this is 101 and 2A is 4. So basically value of A is 2. So this series is 2, 3, 4 up to 99. That says we have to evaluate this series where k varies from 1 to 49 and this is A to k. That means we are talking about second term, fourth term, so it will be this 3, 5 up to 99, and what we'll do is we'll add 1 and subtract 1. Now we know that this is nothing but this is equal to n square, and n here is from 1 to 49 and we have added one more term, so there will be 50 square. So there will be 50 square minus 1, so it is 49 into 51, which is 2499, and that is the answer to this question. Now here the question is, an AP, a GP and an HP have A and B for the first two terms, then show that their n plus 2th term will be in GP if it is this given condition. Now if we talk about this AP, we know that first two terms are a and b, so its common difference will be b minus a, and then its n plus 2th term will be a plus n plus 1 into d, which is a plus n plus 1 into b minus a. We can write as n plus 1b minus na, and that's our first result. Now for this GP, first two terms are again a and b, so in this case common ratio is b by a, so its n plus 2th term will be a, and this is r to the power n plus 1, so it will be this b to the power n plus 1 upon a to the power n, and for this HP, first two terms are a and b, so its corresponding AP will be 1 upon a, 1 upon b, so its common difference is 1 upon b minus 1 upon a, and for this corresponding AP, its n plus 2th term is 1 upon a plus n plus 1 into 1 upon b minus 1 upon a, which is n plus 1 upon b minus na, or we can write n plus 1a minus nb upon ab. Now for this HP, corresponding term will be ab upon n plus 1a minus n into b. Now we have these three terms, and it says these three terms, they are in GP. So if these three terms, they are in GP, we can write Gn plus 2 square, and will be equal to an plus 2 into h n plus 2. Now this g square will be b to the power 2n plus 2 upon a to the power 2n, and this an plus 2 is n plus 1b minus na into, and this h is ab upon n plus 1a minus n into b. Now this b will cancel once, so it will be this 2n plus 1, and we'll take this a also, so it will be this 2n plus 1, so we can write b to the power 2n plus 1 upon a to the power 2n plus 1, it is equal to n plus 1b minus na upon n plus 1a minus n into b. What we'll do is we'll cross multiply, so we can write n plus 1 a b to the power 2n plus 1 minus n b to the power 2n plus 2, and it will be equal to n plus 1 b into a to the power 2n plus 1 and minus n a to the power 2n plus 2. Now we'll take terms of n plus 1 together and n together, so we can write n plus 1, and here we'll take ab common. So if we take ab common, we'll get b to the power 2n minus a to the power 2n, and here will be this n b to the power 2n plus 2 minus a to the power 2n plus 2. Now we need n plus 1 upon n, so we can rewrite this as n plus 1 upon n as b to the power 2n plus 2 minus a to the power 2n plus 2 upon ab into b to the power 2n minus a to the power 2n, which is what we need to prove in this question. Now in this question it is given that x, y, z are in GP, and here it should be x is greater than 1 and not x equal to 1. So it says x, y, z, they are in GP, and we know that if x, y, z are in GP, then log x, log y and log z, they'll be in AP. Now if we add a constant number to each of the terms, then it will still remain an AP. So 1 plus log x, 1 plus log y, and 1 plus log z will be an AP. And if we take the reciprocal, it will be 1 upon 1 plus log x, 1 upon 1 plus log y, 1 upon 1 plus log z. Now reciprocal of an AP is HP. So these three terms, they are in HP. That means correct option is this option B. Now here the question is, prove that a triangle ABC is equilateral if and only if 10A plus 10B plus 10C equals 3 root 3. So it is if and only if. So we have to prove it both ways. So first is, let ABC be equilateral. So let triangle ABC be equilateral. In that case, A equals B equals C equals 60. And in that case, 10A will be equal to 10B will be equal to 10C, and they'll be equal to root 3. And therefore, 10A plus 10B plus 10C is 3 root 3. Now we prove the second part, that let 10A plus 10B plus 10C, it is equal to 3 root 3. Now we need to prove that this triangle is an equilateral triangle. Now we know that in a triangle 10A plus 10B plus 10C, it is equal to 10A into 10B into 10C. If we use AM and GM, then we can write 10A plus 10B plus 10C by 3 will be greater than or equal to 10A into 10B into 10C to the power 1 by 3. Now suppose this is x. So we can write x by 3 is greater than or equal to x to the power 1 by 3, or we can write x to the power 2 by 3 will be greater than or equal to 3. So from here we can write x is greater than or equal to 3 root 3. So for any triangle, this 10A plus 10B plus 10C will always be greater than or equal to 3 root 3. Now in this question we are given this equality, and we'll have this equality if and only if all the three numbers they are same. That means 10A should be equals to 10B and it should be equal to 10C. So from here we'll get A equals B equals C, and therefore this triangle ABC is equilateral. Now the one question that pops up in the head is, how can we use AM and GM if we do not know whether these three numbers they are positive? But we know that 10A into 10B into 10C is 3 root 3, which is a positive number. That means all the three angles A, B and C, they'll be acute. And that's the reason we have used AM and GM in this question. Now here the question is, A1, A2 and A10 be an AP, and H1, H2, H10 be an HP. If A1 equals H1 equals 2 and A10 equals H10 equals 3, find the value of A4 into H7. So let us first talk about this AP, whose first term is 2 and whose 10th term is 3. We can find its common difference. So it will be this 3 equals 2 plus 9D. So its common difference is 1 by 9. Now we have to find its fourth term. So this A4 is A plus 3D, which is 2 plus 1 by 3, and that is 7 by 3, and this is our first result. Now we're going to consider this HP. Now for this HP, now here first term is 2 and 10th term is 3. For its corresponding AP, first term is 1 by 2 and 10th term is 1 by 3. So we can write 1 by 3 equals 1 by 2 plus 9D, or 9D equals minus 1 by 6. Its common difference is minus 1 by 54. Let it be D dash. Now we have to find its 7th term. So we'll find corresponding 7th term of this AP, which is a plus 6 into d, and it will be 1 by 2 minus 6 by 54, which is 1 by 9, and this is 7 by 18. So corresponding term of this HP will be simply 18 by 7, and that's your second result. Now it is asking us to find A4 into H7. Now A4 is 7 by 3 and H7 is 18 by 7. So this is nothing but 6, which is your option D. Now the question is sum of an infinite geometric series is 162. So let the sum be a upon 1 minus r, and this is 162, and sum of n terms will be 160. So it will be a 1 minus r to the power n upon 1 minus r, and this is 160. If the inverse of its common ratio is an integer, find all possible values of common ratio. Now what we'll do is we'll put the value of a upon 1 minus r is 162. So it will be this 162 into 1 minus r to the power n will be equal to 120, or 1 minus r to the power n will be equal to 160 by 162, which is 80 by 81. So from here we can write r to the power n as 1 by 81, which is 1 upon 3 to the power 4. Now it is given that inverse of its common ratio is an integer. So what are the possible values of r and n? Now first possibility is n is 1, and in that case r itself is 1 by 81. Second possibility is n is 2, then r will be plus or minus 1 by 9. And third possibility is if n is 4, then this r will be plus or minus 1 by 3. Now once we have n and r, we can find the value of a. So this a will be nothing but 162 into 1 minus r. So here it will be 162, and this is 80 by 81, which is 160. For this case, it will be 162, 1 plus minus 1 by 9. Now this is 18 into 9 plus or minus 1. So it will be either 180 or 144, and here will be this 162, 1 plus minus 1 by 3, which is 54, and this is 3 plus or minus 1, which is 216, or 162. The fourth power of the common difference of an AP with integer entries added to the product of any 4 consecutive terms of it prove that the resulting sum is square of an integer. So we need to find 4 consecutive terms of an AP. Let these terms be a minus 3d, a minus d, a plus d, and a plus 3d. And for this AP, common difference is 2d. Now it says product of any 4 consecutive terms. So if we multiply them, it will be a plus b into a minus b. We can write a square minus d square into a square minus 9d square, and then we are going to add fourth power of common difference. So fourth power of common difference will be 2d to the power 4. Now we can write this as a to the power 4, and this is minus 10 d square a square plus 9d to the power 4 plus 16d to the power 4, which is a to the power 4 minus 10 a square d square plus 25d to the power 4, which is a square minus 5d square whole square, which is sum of the squares of an integer. Now here the question is, if alpha and gamma are the roots of the equation ax square minus 4x plus 1 equals 0 and beta delta be the roots of the equation ax square minus 6x plus 1 equals to 0, then find the values of a and b such that alpha, beta, gamma and delta, they are in HP. Now we know that if alpha, beta, gamma, delta, they are in HP, then 1 upon alpha, 1 upon beta, 1 upon gamma and 1 upon delta, they'll be in AP. So what we'll do is we'll transform these two equations into the equations whose roots are reciprocal of the roots of given equation. So we'll replace x with 1 upon x. So it'll be this a 1 upon x square minus 4 1 upon x plus 1 equals to 0. So this equation, it will be x square minus 4x plus a equals to 0, and the same way it'll be x square minus 6x plus b equals to 0. So we have two equations, x square minus 4x plus a equals to 0, whose roots are 1 upon alpha and 1 upon gamma, and then we have the second equation, x square minus 6x plus b equals 0, whose roots are 1 upon beta and 1 upon delta. Now these four numbers, they are in AP. So what we'll do is we'll let 1 upon alpha as a, 1 upon beta as a plus d, 1 upon gamma as a plus 2d, and 1 upon delta as a plus 3d. Now for this equation, roots are a and a plus 2d, and for this equation, roots are a plus d and a plus 3d. Now if we write sum of roots for this first one, we can write 2a plus 2d equals 4 or a plus d equals 2, and for the second one 2a plus 4d, it is equal to 6 or a plus 2d equals 3. So from here we get d as 1 and a as 1. So basically for this first equation, roots are 1 and 3, and for this second equation, roots are 2 and 4. Now a is nothing but product of roots. So in this case, a is 3 and b also is product of roots. So this b will be 8. So value of a is 3 and value of b is 8. Now the question is, if the sum of roots of the equation ax square plus bx plus c equals to 0 is equal to the sum of squares of their reciprocals, then find whether b square, c square and ab square are in AP, GP or HP. Now what we are given is sum of roots. That means alpha plus beta is equal to sum of squares of their reciprocals. That means 1 upon alpha square plus 1 upon beta square. So essentially it is alpha plus beta, and it is alpha square plus beta square upon alpha square beta square, which we can also write as alpha plus beta whole square minus 2 alpha beta upon alpha square beta square. Now alpha plus beta is minus b upon a. This is minus b upon a square minus 2c upon a, and this is c square upon a square. We can write as minus b upon a, and here it will be b square minus 2ac upon c square, which we can write minus bc square equals ab square minus 2a square c, or 2 times a square c equals ab square plus bc square, which means these three given numbers, they are in AP, and that is the answer to this question. Now the question is, solve the following equations for x and y. Now we are given that log x base 2, log x base 4, log x base 16, it is equal to y. Now this 4 is 2 square, 16 is 2 to the power 4, and we know that power of base comes as reciprocal. So it will be this log x base 2, it will be this 1 by 2 log x base 2, it is 1 by 4 log x base 2, and this is equal to y. We take log x base 2 common, and then we are left with this infinite GP 1 plus 1 by 2 plus 1 by 4 up to infinite, which is log x base 2, and this is a upon 1 minus r. So it will be this 2 log x base 2. So that's your y, answer first equation. Now we are given that 5 plus 9 plus 13 up to 4y plus 1, and this is 1 plus 3 plus 5 up to 2y minus 1, and this is equal to 4 log x base 4. Now this first sequence, it is an AP with common difference of 4 and number of terms y. So its sum will be y by 2 a plus l, which is 5 plus 4y plus 1, and here it is sum of first odd numbers and total number of numbers is y. So it will be simply y square, and here we can add this 4 as 2 square, so it will be this 2 log x base 2. Now we know that 2 log x base 2 is nothing but y, so we'll write this as y. Now here y and y will cancel, so we can write 2y plus 3 equals y square, or y square minus 2y plus 3 equals 0. We can write y minus 3, y plus 1 equals to 0, and value of y is 3. Now since y is also number of terms, it cannot be negative. So the only value of y we are taking is y equals 3 and not y equals minus 1. So if we take y as 3, then log x base 2 is 3 by 2, then x is 2 to the power 3 by 2, which is simply 2 root 2. So value of x is 2 root 2 and value of y is 3. Now the question is, let alpha and beta be the roots of the equation x square minus x plus p equals 0, and gamma and delta be the roots of the equation x square minus 4x plus q equals to 0, and it says alpha, beta, gamma, delta, they are in GP. They are in GP, then the integral values of p and q respectively are. Now since they are in GP, let the terms be a, AR, AR square, and A, R cube. Now if we write sum of roots, for this first one it will be A, 1 plus R, it is 1, and for the second one, if we take AR square common, it will be 1 plus R, and this is 4. Now A into 1 plus R is 1, so we get R square equals 4, value of R is plus or minus 2. Now if we put R as 2, we'll get A as 1 by 3, and if we put R as minus 2, we'll get this A as minus 1. Now R equals 2 and A equals 1 by 3, it will not give us integral values of P and Q. So we are going to discard it. So the only solution we have in this case is when A is minus 1 and R is minus 2. So here roots are minus 1, 2, minus 4 and 8. Now P is simply product of roots. So in this case P is minus 2 and Q is product of roots of this second equation, which is minus 32, and that's your option A. Now the question is, if the sum of first two n terms of an AP is equal to sum of first n terms of this second AP, then the value of n is. Now sum of first two n terms, so it will be this 2n by 2 and then 2a plus 2n minus 1, and common difference is 3, will be equal to n by 2, 2a plus n minus 1, and here common difference is 2. Now this 2 and 2 will cancel, here this 2 and 2 will cancel, and this n will also cancel, so we'll get this as 6n plus 1, it is equal to n plus 56, or 5n equals 55, that is value of n is 11, and that's your option C. Now here the questions. Let A, B, C, D be in AP. So we are given A, B, C and D. They are in AP and they are positive numbers. So none of them is 0. Then A, B, C, A, B, D, A, C, D and B, C, D, they are in what? Or they are not in what? Now we know that if we divide each term of an AP with a constant number, it will still be an AP. So what we'll do is we'll divide everything with A, B, C, D. So if we divide everything with A, B, C, D, we can write 1 upon B, C, D, 1 upon CDA, 1 upon DAB and 1 upon ABC. It'll be an AP. Now we also know that if we reverse an AP, it'll still be an AP. So we can write 1 upon A plus B, 1 upon DAB, 1 upon CDA and 1 upon BCD. It'll be an AP. And we know that reciprocal of an AP is HP. So it means ABC, ABD, ACD and BCD, they are in HP, and that's your option D. Now the question, let A1, A2 be positive real numbers in GP and let each n, AN, GN and HN be arithmetic mean, geometric mean and harmonic mean of A1, A2, A3 and AN. Find the expression for the GM, G1, G2, Gn in terms of A1, A2, AN and H1, H2, Hn. Now we have a GP and let the GP be A, AR square up to AR to the power n minus 1. Now AN is their arithmetic mean. So we know that AN will be A plus AR plus AR to the power n minus 1 whole divided by n. Now this is nothing but sum of a GP, so it will be A 1 minus R to the power n upon 1 minus R into n. So that's your AN. GN is their geometric mean. So it will be this A into AR into AR to the power n minus 1 whole to the power 1 by n. Now this is A to the power n and here it is R 1 plus 2 up to n minus 1 to the power 1 by n. Now this Gn will be this A to the power n and here will be this R n minus 1 by 2 whole to the power 1 by n, which is A into R to the power n minus 1 by 2, and that's your second result. Now Hn will be n upon 1 upon A plus 1 upon AR up to 1 upon A R to the power n minus 1. Now this again is a GP whose first term is 1 by A, its common ratio is 1 by R, so it will be 1 by R to the power n minus 1 upon 1 by R minus 1. We can simplify this as n into 1 minus R into A R to the power n minus 1 upon 1 minus R to the power n. Now, if we multiply An and Hn, we can write An into Hn will be A 1 minus R to the power n upon 1 minus R into n, and here will be n 1 minus R A R to the power n minus 1 upon 1 minus R to the power n. Now 1 minus R to the power n, 1 minus R will cancel. This n will also cancel. So we'll get this as A square R to the power n minus 1, which is nothing but Gn square. So basically An, Gn and Hn, they are in GP. So for any n, Gn square will be equal to An into HN. Now what it is asking for is GM of G1, G2 and Gn. So we have to find GM of G1 into G2 up to Gn. So this Gn will be this power 1 by n. Now G1 is A1 H1, G2 is A2 H2 and Gn is An Hn whole to the power 1 by n. So expression of this Gm will be A1 A2 An into H1 H2 Hn whole to the power 1 by n, and that is the answer to this question. Now here the question is, suppose A, B, C are in AP, that means twice B equals A plus C, and A square, B square, C square are in GP, that means B square square is equal to A square into C square, or B square equals plus or minus AC. And it is given that A is less than B is less than C, and A plus B plus C is 3 by 2. Find the value of A. Now A plus C is 2B. So you put A plus C as 2B, we get B as 1 by 2. And if B is 1 by 2, we write A into C as plus or minus 1 by 4. And if we put B as 1 here, we get A plus C as 1. So we can write A and the C is plus minus 1 by 4. So it will be plus minus 1 by 4A and it is equal to 1. So we can write 4A square minus 4A plus minus 1 equals 0. And if we add 1 and subtract 1, we can write 2A minus 1 whole square equals 1 plus or minus 1. Now if we take this minus sign, we'll get A as 1 by 2, which is same as B, which is not possible. So we'll need to take this plus sign, and if we take this plus sign, we get 2A minus 1 whole square. It is equal to 2, or 2A minus 1 equals plus or minus root 2. So this A, it will be 1 by 2 plus minus, now root 2 upon 2 is 1 by root 2. Now since this A, it has to be less than 1 by 2, the only value of A possible here is A equals 1 by 2 minus 1 upon root 2, and that's your option D. Now the question is, let AB be positive real numbers so that A, A1, A2 and B, they are in AP. Now common difference is B minus A upon 3. So this A1 will be A plus B minus A upon 3. So it will be 2A plus B upon 3. And in the same way, A2 will be A plus 2B upon 3. So we have A1 and A2. Now it says A, G1, G2 and B, they are in GP. So for this question, it should be G1, G2. Now here, R will be B upon A to the power 1 by 3. So this G1, it will be A to the power 2 by 3, B to the power 1 by 3, and G2 will be A to the power 1 by 3 and B to the power 2 by 3. And this third one is A, H1, H2 and B, they are in HP. Now this is same as this first one because it's corresponding 1 upon A, 1 upon H1, 1 upon H2, 1 upon B. They'll be in AP, and for this AP we are going to use 1 upon A and 1 upon B, but we have to take the reciprocals. So for this we are going to write H1 as 3 upon 2 upon A plus 1 upon B, that is 3AB upon 2B plus A, and H2 will be 3AB upon 2A plus B. So now we have A1, A2, G1, G2 and H1, H2. Now this first part is G1, G2 upon H1, H2. So we multiply them, we can write G1, G2 upon H1, H2. Now G1, G2 is product of these two terms. Now A to the power 2 by 3 into A to the power 1 by 3 is A, and B to the power 1 by 3 and B to the power 2 by 3 is B. So it will be simply AB upon H1, H2. Now this is 3AB upon A plus 2B, and this is 3AB upon B plus 2A. Now this AB and AB will cancel, so it will be equal to A plus 2B into B plus 2A upon 9AB, which is this right hand side. Now we'll also need to prove that A1 plus A2 upon H1 plus H2 is also equal to this same result. So if we take A1 plus A2, A1 plus A2, it will be 2A plus B, and this is A plus 2B, which is 3A plus 3B upon 3. So it will be nothing but A plus B. And then if we write H1 plus H2, we'll take 3AB common, and then it will be 1 upon 2B plus A plus 1 upon 2A plus B. So it will be this 3AB, and this is 3 times A plus B upon 2B plus A and 2A plus B. Now if we divide them, we can write A1 plus A2 upon H1 plus H2, there will be A plus B upon 9AB A plus B into A plus 2B into B plus 2A. Now this A plus B will cancel, and this is what we need to prove in this question. Right, the question is, if A, B, C are in AP and A square, B square, C square are in HP, then prove that either A equals B equals C or AB minus C by 2 form a GP. Now in this case it says A, B, C, they are in AP, that means B minus A is equal to C minus B, and let it be equal to D, which is its common difference, and A square, B square, C square, they are in HP, which means 1 upon A square, 1 upon B square and 1 upon C square, they are in AP. So you can write 1 upon B square minus 1 upon A square will be equal to 1 upon C square minus 1 upon B square. Now this is A square minus B square upon A square B square will be equal to B square minus C square upon B square C square. Now here B square will cancel, so we can write A plus B into A minus B upon A square will be equal to B plus C into B minus C upon C square. Now A minus B is minus D and B minus C is minus D. So this is minus D and this is minus D. So if we cancel this out, we'll get this one result that D is 0. And if D is 0, it means A equals B equals C. So one of the results that we can get here is A equals B equals C. Now if we consider D is unequal to 0, then we can write A plus B upon A square will be equal to B plus C upon C square. So AC square plus BC square will be equal to A square B plus CA square. Now we'll take terms of AC together. So it will be this AC into C minus A and it will be equal to B into A square minus C square. Now A is unequal to C because D is unequal to 0. So here we can cancel C minus A. So we can write minus AC and that will be equal to B A plus C. And since ABC are in AP, we can write B equals A plus C by 2 or A plus C as 2B. So it will be this 2B square. So we'll get this condition that 2B square equals minus AC or AB and minus c by 2, they form a GP. So we'll get two conditions, either a equals b equals c or ab minus c by 2 will form a GP. Now the question is, if a, b, c are positive real numbers, then prove that 1 plus a, 1 plus b, 1 plus c whole to the power 7 is greater than 7 to the power 7, a to the power 4, b to the power 4 and c to the power 4. Now if we look at this left hand side, then we have 1 plus a into 1 plus b into 1 plus c, which we can write as 1 plus a plus b plus c plus ab plus bc plus ca plus abc. Now there are altogether 8 terms, and if we use am and gm using all these terms, we'll get 8 and not 7, and what we need is 7 terms. So what we'll do is we can write 1 plus a, 1 plus b and 1 plus c will be strictly greater than a plus b plus c plus ab plus bc plus ca plus abc. So what we have done is we have dropped this one, and that's how we get this condition at strict inequality. Now what we'll do is we'll divide everything with 7. Now this is arithmetic mean of these 7 numbers. So arithmetic mean is always greater than or equal to the geometric mean. Now in the geometric mean, we'll have a into a into a into a 4 times. So there'll be a to the power 4, b to the power 4, c to the power 4 whole to the power 1 by 7. And considering these two, we can write 1 plus a, 1 plus b into 1 plus c will be greater than 7 into a to the power 4, b to the power 4, c to the power 4 to the power 1 by 7. Now we'll take 7th power, so we can write 1 plus a, 1 plus b, 1 plus c whole to the power 7 will be strictly greater than 7 to the power 7 and a to the power 4, b to the power 4, c to the power 4, which is what we need to prove in this question. Now here the question: in a quadratic equation ax square plus bx plus c and delta is b square minus 4ac, which is its discriminant, it is given that alpha plus beta, alpha square plus beta square and alpha cube plus beta cube, they form a GP where alpha and beta are roots of this equation, then which of the following is true? Now if they are in GP, then alpha square plus beta square whole square will be equal to alpha plus beta into alpha cube plus beta cube. Now this is alpha to the power 4 plus beta to the power 4 plus 2 alpha square beta square, and there will be alpha to the power 4 plus beta to the power 4 plus alpha beta cube plus beta alpha cube. Now alpha to the power 4, beta to the power 4 will cancel, and from everything we'll take alpha beta common, so it will be this alpha beta, and then we'll have alpha square plus beta square minus 2 alpha beta equals 0, or we can write alpha beta into, and this is alpha plus beta whole square minus 4 alpha beta, it should be equal to 0. Now alpha upon beta is c upon a, and this is b square upon a square minus 4c upon a equals 0, which we can write c into b square minus 4ac equals to 0, which is c delta equals to 0, and that's your option C. Now here the question is, let TR be the rth term of an AP whose first term is minus 1 by 2. So first term is minus 1 by 2 and common difference is 1. Now its rth term will be a plus r minus 1 into d, which is r minus 3 by 2, or we can write simply 2r minus 3 by 2. Now TR plus 1th term will be 2r minus 1 by 2. TR plus 2th term will be 2r plus 1 by 2 and t r plus third term will be 2r plus 3 by 2. Now it says we need to find this series which is summation r varies from 1 to n under root of 1 plus tr plus 1, tr plus 2 and tr plus 3. That will be this summation r varies from 1 to n and this is under root of 1 plus and this is 2r minus 3 into 2r minus 1, 2r plus 1, 2r plus 3 upon 16. Now this is a plus b into a minus b. So we can write this sum as this summation r varies from 1 to n and it will be this under root of 1 plus and this is 4r square minus 1 into 4r square minus 9 whole divided by 16. Now we take 1 by 4 common and it will be this summation r varies from 1 to n and here it will be this 16 plus 16 r to the power 4 minus 10 into 4r square plus 9. Now this is 1 by 4 summation r varies from 1 to n and it will be this 4r square whole square minus 10 into 4r square plus 25. So this is a square plus b square minus 2ab and which is a minus b whole square. So it will be this 1 by 4 and then summation r varies from 1 to n 4r square minus 5. Now this sum will be 1 by 4 and 4r square is n plus 1, 2n plus 1 whole divided by 6 and minus 5n. So this sum it will be n plus 1, 2n plus 1 by 6 and minus 5n by 4 and that's your option A. Write the questions. Find the coefficient of x to the power 8 in this polynomial which is x minus 1, x minus 2, x minus 3 up to x minus 10. Now there are 10 terms in the expression. So highest power of x will be x to the power 10. If someone is going to ask you to find coefficient of x to the power 10, it is simple. It will be simply 1. What about if we need to find coefficient of x to the power 9? Now we get x to the power 9 when these 9 x's from these 9 brackets they get multiplied to itself and then this x to the power 9 will get multiplied to minus 1. So we'll get minus 1 x to the power 9. We'll get x to the power 9 when all these remaining x to the power 9 gets multiplied with minus 2. So it will be minus 2 x to the power 9. It will continue up to minus 10 x to the power 9. So coefficient of x to the power 9 will be simply minus 1, minus 2, minus 3 up to minus 10. There will be minus 1 n plus 1 by 2 and there will be minus 55. Now in this question they have not asked for x to the power 10 or x to the power 9. What they are asking for is x to the power 8. So we need to find coefficient of x to the power 8. Now we get x to the power 8 when 8 of the x's get multiplied to themselves and then these x to the power 8 it gets multiplied with constant term of 2 brackets. So it will be 1 into 2, 1 into 3, 1 into 10 and will continue up to 9 into 10. So basically it is product of all the terms from 1 to 10 taken 2 at a time. Now we know that 1 plus 2 plus 3 up to 10 whole square, it is n plus 1 by 2 whole square. Now we can right? This is a square plus b square plus 10 square plus 2 times and then 2ab, bc, ac, all these terms. So basically here what we'll get is this series which we are looking for, and let the series be S. So it will be this 2s and it will be equal to 55 square. Now this is n plus 1 to n plus 1 by 6 plus 2s and it will be equal to 55 square. So we get 2s is 2640 or value of s is 1320. So coefficient of x to the power 8 will be 1320, and that's your option B. Now let us take another question, and here we need to find the sum of the series up to infinite terms. What we'll do is we'll find sum up to n terms. Now in the numerator we have the series 2, 6, 12 and 20 and so on. We'll write the differences. 6 minus 2, 4. 12 minus 6, 6. 20 minus 12, 8. Now this is 2 and this is 2. Now we can use the shortcut. This is 2a. This is 3a plus b. And this is a plus b plus c. Now clearly a is 1. And if we put a as 1, we'll get b as 1. And if we put a and b as 1, we'll get c as 0. So its nth term will be n square plus n. Now in order to solve this question, we have to write general term of the series. It is TR and it will be in the numerator we'll have r square plus r. In the first term it is 1 cube, second term it is 1 cube plus 2 cube. So it will be 1 cube plus 2 cube up to r cube. Now we can write this as TR equals r into r plus 1 and this is r plus 1 by 2 whole square. As r plus 1 will cancel, so it will be 4 upon r plus 1, which we can also write as TR equals 4 and this is 1 upon r minus 1 upon r plus 1. Now we need to find sum of n terms. So Sn it will be 4. And we put t as 1, it will be 1 upon 1 minus 1 upon 2. If we put t as 2, it will be 1 upon 2 minus 1 upon 3. 1 upon 3 minus 1 upon 4. And will continue up to 1 upon n minus 1 upon n plus 1. Now here 1 by 2, 1 by 3 will cancel. So what we'll get is Sn equals 4 into 1 minus 1 upon n plus 1, which is 4n upon n plus 1. Now we need to find sum up to infinite. Now S infinity is limit n tends to infinite, Sn. Now here highest power of n is 1. So its answer is 4 upon 1, which is simply 4. And that is the answer to this question. Now let us take another question. And here the question is we need to find sum of first 10 terms of this series. Now what we'll do is rather than finding sum of first 10 terms, we'll find sum of first n terms. Now we can have this series as 7 upon 2 square into 5 square plus 13 upon 5 square into 8 square plus 19 upon 8 square into 11 square up to n terms. Now we can write this series S as, now 7 is 2 plus 5, so it will be 2 plus 5 upon 2 square into 5 square. 13 is 5 plus 8, so it will be 5 plus 8 upon 5 square, 8 square. This is 8 plus 11 upon 8 square into 11 square up to n terms. Now, if we look at these first terms in the denominator, 2, 5, 8, it is an AP. So we'll find nth term of this AP or rth term. So it will be a plus r minus 1 into common difference, which is 3. So there will be 3r minus 1. So we can write its general term TR as 3r minus 1 whole square. Now this next term is 3 more than the first term. So there will be 3r minus 1 plus 3. So there will be 3r plus 2 whole square. And the numerator, it is simply the addition of these two terms. So it is 3r minus 1 plus 3r plus 2. Now since we have to solve this question, we need to use method of difference and we have to introduce a minus sign. So what we'll do is, we'll multiply and divide it with 3r plus 2 minus 3r minus 1, and which essentially is 3. So we'll multiply and divide it with 3. Now this is a plus b into a minus b. So we can write 1 by 3. And this is 3r plus 2 whole square minus 3r minus 1 whole square upon 3r minus 1 whole square into 3r plus 2 whole square. Now we'll split this. We can write this as tr equals 1 by 3. Here 3r plus 2 square will cancel. So we'll get 1 upon 3r minus 1 square minus, and here 3r minus 1 will cancel. We'll get 1 upon 3r plus 2 whole square. Now we'll write its first term t1. It'll be 1 by 3. And if we put r as 1, we'll get this as 1 upon 2 square minus, and it'll be 1 upon 5 square. For second term, we'll put r as 2. So there'll be t2 equals 1 by 3, and it is 1 upon 5 square minus 1 upon 8 square. Third term, it'll be 1 by 3, 1 upon 8 square minus 1 upon 11 square, and we'll go on. And its nth term will be Tn equals 1 by 3, 1 upon 3n minus 1 whole square minus 3n plus 2 whole square. Now we add them. Now Sn is sum of these n terms. So if we add all these terms, we'll get Sn. Now here 5 square will cancel, 8 square will cancel, 11 square will cancel. Now here we have 1 upon 2 square. So what remains is 1 upon 3n plus 2 square. So it will be 1 by 3. 1 upon 2 square minus 1 upon 3n plus 2 square. And that is solve this series up to n terms. Now in this question, what they have asked for is sum of n terms. So we'll put n as 10. So it will be 1 by 3. And this is 1 by 4 minus, and this is 1 by 30 plus 2, 32 square, which is 1024. Now this is 1 by 3. And denominator will be 1024, and here will be 256 minus 1, 255. If we divide it with 3, there will be 85 upon 1024. So answer to this question is 85 upon 1024, which is your option B. Now here the questions, we need to find sum of n terms of this series, which is given as this summation r varies from 1 to 10, we'll find it for general term n. From 1 to n, r upon 1 minus 3r square plus r to the power 4. Now this again is similar to the question which you have done previously. Now r varies from 1 to n. This is r, and what we'll do is, we'll write this is 1 minus 2r square plus r to the power 4 minus r square, which is this summation r upon r square minus 1 whole square minus r square, which is this summation r upon, now this is a plus b into a minus b, so it will be r square minus r minus 1 into r square plus r minus 1, and that's your r term. Now we can use partial fraction. We can write this as 1 by 2, and it is 1 upon r square minus r minus 1, and this is minus 1 upon r square plus r minus 1. Now here r square will cancel, 1 will cancel, we'll get this as 2r, and this 2 will also cancel, so we'll get the same term. Now this first term is 1 by 2 minus 1 minus plus 1. Second term is 1 by 2. Now this is 4 minus 3, 1. And if we put r as 2, there will be 4 plus 2, 6 minus 1. So it will be 1 by 5. For r equals 3, it will be 1 by 2. And then it will be 9. 9 minus 4, 1 by 5 minus. And here it will be 9 plus 3, 12 minus 1, 11. And its nth term will be 1 by 2 1 upon n square minus n minus 1 upon 1 upon n square plus n minus 1. Now if we add all these terms, we'll get our Sn. So this Sn, it will be these terms, they'll cancel 1 by 2, and this is minus 1 minus 1 upon n square plus n minus 1. Now we need to find the sum of 10 terms. So we'll put n as 10. So it will be this minus 1 minus 1 upon, and this is 100, 110 minus 1. So it will be 109. So it is minus 110 upon 2 into 109, which is minus 55 upon 109. And that's your option D. Now here the question is, we need to find the value of this summation. N varies from 3 to infinite 1 upon n to the power 5 minus 5n cube plus 4n. So its general term or its nth term will be 1 upon, we'll take n common, and that will be n to the power 4 minus 5n square plus 4, which we can also write as n, and this is n square minus 1 and n square minus 4. Now this is a plus b into a minus b, so we can write its general term as 1 upon n minus 2, n minus 1, n plus 1, n plus 2. Now difference between these two terms is 4. So what we'll do is we'll multiply with 4 and we'll divide it with 4. So we can write its general term or its rth term as 1 by 4, and here it will be this r plus 2 minus r minus 2 upon r minus 2, r minus 1, r plus 1, r plus 2, and we'll split it in two parts. So we'll write this rth term as 1 by 4. Now here r plus 2 will cancel, so we'll get 1 upon r minus 2, r minus 1, r plus 1 minus 1 upon, and here it will be r minus 1, r plus 1, r plus 2. Now this summation, it starts from r equals 3. So this first term, suppose it is t1 dash will be 1 by 4, and if we put r as 3, we'll get this as 1, 2, 3, 4, and here it will be 2, 3, 4, 5. And the second term will be 1 by 4. This is 2, 3, 4, 5 minus 3, 4, 5, 6. I'll continue up to n terms. So there will be 1 by 4, and this is n minus 2, n minus 1, n plus 1 minus 1 upon n minus 1, n plus 1, n plus 2. Now if we add them all up, all these terms, they'll cancel. So sum of n terms for this series, it will be 1 by 4, and this is 1 by 24 minus 1 upon n minus 1, n plus 1 into n plus 2. So that is sum of n terms. Now if we find this sum up to infinite, so it will be limit n tends to infinite Sn, and there will be 1 by 4 into 1 by 24 minus, and this is 0, so it will be 1 by 96, and that's your option B. Now here the question is, we need to find the value of this series, which is this summation r varies from 1 to infinite, and this is 4r plus 5 into 5 to the power minus r upon r into 5r plus 5. And that's your S infinite. Now what we'll do is we'll first find sum up to n terms. We'll write its general term will be 4r plus 5 into 5 to the power minus r upon r, and this is 5r plus 5. Now we can write this as 5r plus 5 minus r into 5 to the power minus r upon r into 5r plus 5. Now we'll split it in two parts. Now for this first one, 5r plus 5 will cancel. So we get 5 to the power minus r upon r minus, and here r will cancel, and if we take 5 common, there will be 5 to the power minus r minus 1 upon r plus 1, and that's your rth term. Now this first term will be 5 to the power minus 1 upon 1, and this is 5 to the power minus 2 upon 2. Its second term will be 5 to the power minus 2 upon 2 minus 5 to the power minus 3 upon 3, and it will continue up to its nth term, which is 5 to the power minus n upon n minus 5 to the power minus n minus 1 upon n plus 1. Now if we add them, we'll get sum of n terms. Now these terms, they'll cancel. So sum of n terms will be simply 5 to the power minus 1 minus 5 to the power minus n minus 1 upon n plus 1. And that is the sum of first n terms. Now in this question, we need to find S infinite. So S infinite, which is simply S, will be this limit n tends to infinite Sn. Now this is 1 by 5 and then minus. Now 5 to the power minus infinite is 0 and this is infinite. So this expression will be 0. So value of S is simply 1 by 5. And that's your option A.